दिनर पानी ला बेटे, हाथ धो के जरा पीने। हेलो, गुड इवनिंग।
Good evening, ma'am.
टर्न ऑन योर वीडियो बेटा। बिना ब्रिंग बेटे में लोटा भी लगेगा इतना सब बस। क्या है? जा। Just a minute, let me check for it. We were about to start open chain hydrocarbon, right?
Yeah.
Just a minute. Okay.
Yeah. Yes, ma'am.
Okay. See here what is given about the open chain hydrocarbons. Open chain hydrocarbon, we were further classified it in a saturated and unsaturated hydrocarbons, right? The chart must be there with you, correct? And then saturated are nothing but the alkanes, right? Yeah. So what they said, the open chain hydrocarbons, they are also called the aliphatic hydrocarbons. Okay. Open chain hydrocarbon has another name, that is what? Aliphatic hydrocarbons. They are further classified into saturated and unsaturated, correct? So among that, the first one is the saturated, that is alkane. Okay. So alkane are the saturated open chain hydrocarbons. Saturated means it consists only carbon-carbon single bond. Okay. Second, they have only single bonds, the same which I have told you now. Their general molecular formula is CnH2n plus 2, which I already told you. Correct? Yeah. And the first member of alkane has only one carbon atom. Correct? Yeah. And the first 10 alkanes and their molecular formulae are as follows: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. The same already I gave you. From first member, you just have to add this group, CH2 group, to the next one.
Yes, ma'am. The homologous series.
Yes. And the alkanes are called paraffins. Another name for the alkane is paraffins. Please note. Now, if one hydrogen atom is removed from the alkane, then it forms alkyl group. What does it form?
Alkyl.
Yes. Yesterday I have shown you CH4 is a methane, and if you remove one hydrogen from it, what happens? It will convert into CH3. And this CH3 is what?
And
Methyl.
that's alkyl, methyl.
Alkane, methane. It lost its one hydrogen minus H, it convert into alkyl. Same for all the alkanes. Means like methane can be converted into methyl, Ethane can be converted into ethyl, propane can be converted into propyl in the same way.
Yes,
Okay?
ma'am.
Keep it in your mind. Okay.
Ma'am,
what-
for the last chapter, you have not uploaded the notes.
I have to provide you notes.
Yeah. No, like the PDF, you said you would provide that.
Okay. I'll post it in the list then.
Yeah.
Okay? By the end of period. Fine. Fine. So, if one hydrogen is removed from the alkane, then it forms the alkyl group. Alkane minus 1H, it converts into alkyl group.
Alkyl.
For example, methane, when lost with one hydrogen, it is methyl CH3 group with one valency. Ethane, when lost with one hydrogen, here it is ethyl C4.
Ma'am, is that a minus CH3 and minus CH2H5?
Not minus, because carbon has a valency what? 4. So
Mm-hmm.
only would be present. So one valencies remain as it is, that is denoted by this bond.
Ma'am, one valency. Okay.
3 plus 1, 4.
Hmm.
Got it?
Okay,
So
ma'am.
can be attached to any of the atom or group of atom.
Okay, ma'am.
Right?
Mm-hmm.
And for ethyl also, it's not a minus, it's a bond.
Okay.
Okay?
Mm-hmm.
Clear?
Yes, ma'am.
Now see the next, alkene. About alkene, what is given? Alkenes are unsaturated open chain hydrocarbons. Means it contain what? Carbon-carbon double bond. Right? Its general formula is NH2N. This is also I gave you earlier.
Yes, ma'am.
The first member of alkenes has the 2 carbon, because if carbon-carbon double bond need to form, then 2 carbon at least it is essential, isn't it?
Yeah.
So the first 9 members of alkenes are given. First member is C2H4. Correct? Because
Yeah.
due to the by formula you can form the first member. Okay? That is
Yes, ma'am.
ethane.
Ethane.
Now,
Ethene.
when you just
Ethene.
have to add what? CH2. Okay? Each
Mm-hmm.
member, here it will be form what? C3H6. Then again plus CH2. You will get C4H10. So H8, sorry, not 10. In that manner. See, check it out. Correct?
Yeah.
Ethene, butene, so on, pentane,
And they have
hexane,
double bonds. Yeah, okay.
and decane.
Yes,
Okay,
ma'am.
means A and E should be replaced with E and E.
Ethane. Surname changes.
And alkenes are also called olefins. This is important. I
Olefin.
don't MCQ it asked. Yes.
Okay, ma'am.
Alkanes are called paraffin, whereas alkenes are called olefins. Yeah.
Almost. Yeah.
Next is about alkynes. Alkynes are unsaturated open chain hydrocarbons again, because it has carbon-carbon triple bond. Right?
Yes, ma'am.
Okay. And if any atom should have the carbon-carbon double bond, that time it must consist at least 2 carbons in it. So its first member have 2 carbons in it. Okay.
Okay.
Its general formula is C2N minus 2.
Even for alkenes, the first carbon has to have there should be at least 2 carbons, right?
Carbons, yes. Because carbon-carbon double bond need to be formed, right?
Yes, ma'am.
From them, you have to remove 2 hydrogen to make it into alkyne, to convert it into alkyne. Okay.
Yeah.
So what is formed due to loss of 2 hydrogen? The same we have seen for the ethane to ethene. Now ethene to ethyne. Okay.
Yeah.
Yeah. So it becomes C2H2. By the formula also you can do it.
Yeah.
So this is ethyne, and then to the next member you just have to add what? CH2 group. C3H4, C4H6, C5H8, so on. Ethyne, propyne, butane, pentane, heptane, octane, nonine.
Yes, ma'am.
Yeah.
Ma'am, how again do we find this from alkanes? How do you find alkynes? How many number of electrons you need to minus?
I think I have shown you for the ethane last time.
Yeah, ma'am, could you show it again? Just
Okay. Carbon-carbon, single bond. Valency need to be satisfied. 1, 2, 3, 4, correct?
yeah.
Then 1, 2, 3, 4, correct?
Yeah.
Now from here, if 2 hydrogen has been minus,
Mm-hmm.
1 electron shared from it, it will be given to form the bond in
Yeah.
between carbon, and it will take its 1 bond and form H2 molecule and go.
Yes,
Isn't
ma'am.
it? You get carbon-carbon double bond then over here. Then 2
Yeah.
bonds are in this valency need to be satisfied. 2 more hydrogens remain as it is. Correct?
Yes.
And if it loses 2 hydrogen, right?
Yeah.
In the same way, carbon-carbon triple bond will be formed because already 2 bonds, 1 more bond would be formed in between by the loss of 2 hydrogen. Correct?
Okay, okay,
This
understood.
bond has a two electrons. Now, 1 electron will come here, 1 electron will come here, another electron will go with hydrogen. Right.
Yeah,
So 1
okay,
electron
understood.
from here and 1 electron from here will be formed new bond. For the
Yeah.
new single bond, to formation of single bond, what is required? 2 electrons.
Yes, ma'am. Okay, understood.
Here will be hydrogen and here also hydrogen.
Okay. Yeah.
Now, alkynes are also called olefins. Means unsaturated hydrocarbons are olefins and saturated are paraffins.
Okay, ma'am.
Okay. Fine. Now we are going to see the nomenclature of hydrocarbon. It's very important. If you can note down, it's very
Okay, ma'am.
easy to understand if you note down this. Fine. So the study about the names of hydrocarbon and the carbon compound is called nomenclature. International
The
Union
study
of
of names of the
International Union of Pure and Applied Chemistry (IUPAC) have framed the following rules for writing the name for organic compounds
yeah.
or any of the carbon compound. First one, what you have to do? The condensed formula is to be written in the structural formula of the compound is given. Okay. What has been the condensed formula is to be written if the structural formula of the compound is given. What does it mean? If your ethane structure is like this is a structural formula for the ethane, correct?
Yeah.
It should be written as, this is what? CH3.
CH3.
This is
And
also 3.
CH3.
Or else you can write it in this form as well, C2H6.
So you can write it in both ways, okay.
But then this is a molecular formula. This is molecular formula. It's not a condensed formula.
Yeah. So the structural condensed one is CH3.
This is molecular formula. This is structural formula. Okay. And this will be condensed formula.
Yes, ma'am.
Why you have to write the condensed formula? To identify the
Make it
longest
easier,
carbon
right?
chain. To identify the longest carbon chain.
To identify the longest carbon chain. Ma'am, how?
If it would be in condensed form, carbon chain can be identified easily.
Ma'am, how?
Obviously, hydrogen would not be to surround to that carbon, and you won't get any sort of confusion to identify the longest carbon chain.
I didn't get you.
Now here see, if I have to write number 1, 2, I can give in that manner as well, but then hydrogens are surrounded, right?
Yeah.
And it looks so clumsy. To make it
Yes,
simple, you have to
it
write
looks
in this
very...
manner. Yes.
Oh, okay, okay.
But to make understanding simple,
Yeah.
we have to convert it into condensed.
Okay.
Second, the parent chain is to be determined if hydrocarbon is branch compound. Right? What they said? The parent chain, the chain has most carbon atom. The one which I said you yesterday is to be determined if hydrocarbon is branched compound. If given hydrocarbon is a branch one, you have to select the longest possible chain of carbon.
Yes.
Okay. Yeah. Then the third one, the root word is fixed base on a number of carbon atoms present into the parent chain. Okay. The
Yeah.
root word is fixed based on the number of carbon present into the parent chain. For
So the entire the way you name it, the nomenclature yesterday you explained, that
one
involves.
carbon it is methane. For second carbon, 2 carbon it is ethane. For 3 carbon it is propane. So those parent names are fixed. Those root
Yeah.
words are fixed. Right. Now the given structure is checked for the presence of any double or triple bond. If double bond, then A and E should be converted into E and E.
Yani.
Right. And if triple bond, then A and E should be converted into Y and E.
Yeah.
Correct?
Name changes, yes.
The corresponding suffix A and E, Y and E is added to the root word. Correct?
Yeah.
Just a minute. Huh? Okay. Am I audible now?
Yes, ma'am.
Okay. See now, what is given over here? If double bond or triple bond is present, then its position is to be maintained in between the root word and the suffix.
Ma'am, yesterday we did
If
only with
double
single
bond or
bonds, right? So how did you do it?
yeah, we have did only single bond. That's what I told you earlier. Like if double bond and triple bond is present, that time also we have to like manage. We have to change the name accordingly.
Yeah.
But you're not, isn't it? With a functional group. Yeah.
I'm sorry.
Yes. The functional and triple bond are also called as the functional group, right? And these are
Yes.
called as primary functional groups. These are what? Primary functional group. Keep it in your mind.
Okay.
Okay. Now, if a double or triple bond is present, then its position, whether it is present at first carbon, second carbon, third carbon, okay,
Yeah.
it is mentioned in between the root word and the suffix.
As in?
This is your word. And suffix means your substituent, if any present.
Yes, ma'am. Could you give me an example?
Okay. Yeah, we are going to see. We are going to see the example. Now,
Okay.
the branch chain name is written as the prefix to the word by mentioning the position. Okay.
Yeah, the two
Am I
or the three.
audible?
Ma'am, your
Yeah.
voice is
Am I
breaking.
audible?
Your voice is
Now,
breaking.
now,
Yeah, okay.
I'll keep it here so we get the range. Fine, not an issue. Okay. See here, the double bond and triple bond, if it is present, then its position is to be mentioned in between the root and the suffix, if any.
Mm-hmm.
Then the branch chain name is written as prefix to the root word by mentioning its position. I'll let you know the example. Here one is given, right?
Yeah.
Structure is there with you. CH3, CH2, C double bond CH and CH3, correct?
Yes, ma'am.
This is the structure. As per our rule, first of all, we have to write the numbers, correct?
Yeah.
Yeah. And we have to start the numbering from the end from where your like this one is nearby. Double bond is nearby. This is a CH, okay? H is the
So
remaining.
ma'am, from the left, from the right.
Yeah. So your first, second,
Third.
third, fourth, and fifth, correct?
Yes, ma'am.
Okay. So this will be the parent, and its parent is what?
Pentane.
Pentane. Correct?
Mm-hmm. But ma'am, here it's pentene, right? Because there's a double bond present.
Second thing is what you have to analyze, whether double bond or triple bond is present, correct?
Yeah.
If it is present, then you have to change its suffix. Is
Yes.
it?
Yes, ma'am.
Pent is what your parent root word, correct?
18, yeah.
Yeah. Then here dash I'm going to write E-N-E. Pent, and here it is E-N-E. E-N-E represent your carbon-carbon double bond present in a compound, correct?
Yeah.
So this is your root, this is your suffix,
Suffix.
right? This is
Yeah.
what? Root. This is your suffix, right?
Yes, ma'am.
In between these two, you have to mention the position of this double bond. So which position it is attached? In between 2 and 3 double bond is present, right?
Yeah.
So you have might be confusion like whether I have to write 2 or 3.
Yeah.
So you have to write lowest possible. 2.
Okay, the lowest.
Understand?
So,
Okay.
ma'am, its name it's pen to in.
Pent to in.
Wow, okay, that's
Understood?
good.
Yes. So here see pent to in and pent 3 in is wrong.
Okay.
Understood?
Yes.
Clear?
Yes, ma'am.
See the another example here it is given. CH3, CH2, CH2, CH, CH2, CH3, and this CH3. CH has a like bond
Bond. Yeah.
constituent as CH3. So again, numbering you need to do from the side where branching is nearby.
Yes, ma'am.
Either functional group is nearby or branching is nearby. So
Yeah.
from 1, 2, 3, 4, 5,
Bye.
6. 6 carbon in a chain. So your parent is hexane, right?
Yes, ma'am. Hexane.
Double bond is present?
No,
No.
ma'am.
Correct? So directly hexane we can write. Isn't
Yeah.
it? Bond or triple bond, if it is present, then only we have to like separate it as a root and suffix. Right? So directly we
So,
can.
ma'am, if a double bond is present, we take the numbering which is the lowest. But if there's only a single bond, then we take the
Directly
place
parent
where
name you
the,
have to take. Directly parent name for the single bond.
yeah.
You need not to like segregate it as a root and suffix there.
Yes, ma'am.
Okay, fine. Now hexane you have written as a root word, correct? Now if
Yeah.
you see at the third carbon, your methyl group is present.
Yes, ma'am.
3 methyl hexane,
Hexane.
correct?
Yes, ma'am.
If you numbered it from here, it becomes 4th. But then you have to start numbering from the end from where your branching is nearby.
So it becomes wrong if you don't do that.
Understand? So if you don't follow the rule, your answer would be wrong.
Yeah.
Now see the next one. They have given the structure. CH3, CH, CH3, CH. Here what it is? Iodine or what? CH3 only, yes. CH3, CH2, CH3. Correct?
Yeah. So, ma'am, this is again a single bond. So we start from right to left. I mean, left to right. The
Because
numbering.
is nearby from here, right?
Yeah.
1, 2, 3, 4, 5. Correct?
Mm-hmm.
1, 2, 3, 4, 5. Pentane will be the parent, right?
Mm-hmm.
Isn't it?
Yes, ma'am.
You can see second position and third position, same group is present.
Then it would be 2,3-methyl pentane.
2, 3 dimethyl. 2, na?
Dimethyl pentane. Ma'am, what if no, that's not even possible. Okay, never mind.
If 1, then it is mono. If 2 same group, then it is di. If 3 same group, then it is tri. If 4 same group, then it is tetra.
Tetra. Yeah.
Already I told you this, isn't it?
Yeah.
Yeah. Clear?
Yes, ma'am.
Fourth one. C, CH3, 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 C, CH2, CH3, right? This is a
Mm-hmm.
structure. Again, numbering will be start from here 1, 2, 3, 4, correct?
Yeah.
So this parent will be butane, isn't it?
Yes, ma'am.
So you can check at the second carbon, 2 methyl groups are present. So it will be 2, 2 dimethyl butane.
Yes, ma'am.
Correct?
Ma'am, can you just note those rules down?
Sorry?
The rules given by IUPAC for nomenclature. Can I note them down?
You can, I'll give you it. Just a minute. Let me scroll it up. Go for it.
Yes, ma'am, done.
Yeah. Okay, we are going to see the homologous series. What does it mean?
Mm-hmm.
Then we will see few functional groups, okay?
Okay, ma'am.
And then the nomenclature for those functional groups one by one.
Okay.
Yeah. What are you doing, better? Your video is off.
Yes, ma'am, just give me 1 minute.
Yeah, sure. See what is given about the homologous series. What is a homologous series? It is a group of carbon compounds which have same molecular formula, similar structure, and similar chemical properties. But the consecutive member or the successive member or very next member differ by CH2 group or 14 unit mass.
14 unit
It's called
mass.
homologous series.
Yes, ma'am.
So homologous series of alkanes already we have seen. I have
Yeah.
So that is what? A group of compound, right? Which has molecular formula, same general molecular formula it should be, okay? Same general formula or general molecular formula. Then similar structure and similar chemical properties. But the consecutive member or successive or the very next member differ by either CH2 group or 14 unit mass is called the homologous series.
Yes, ma'am.
And that is given for the alkane. If you want to know the definition for homologous series, you can. Because this can be asked number of times. Already asked number of times. It can be asked this year as well.
Okay, ma'am.
And what is the functional group?
Ma'am, the double bonds and triple bonds.
Yeah, the atom or group of atom. Actually, it should be the group of carbon compound which have a same general formula. See, general formula, same functional group. Don't write structure. Same functional group, having similar chemical properties, but rest all things. Okay, whatever given. So these two things, molecular formula and same functional group. Okay, this you need to change. And what is the functional group? An atom or a group of atom which is responsible for the properties of compound is known as functional group.
Yes, ma'am. So, ma'am, basically the double and triple bonds, right, are functional groups. So, ma'am, what do you mean by the group of atoms responsible for
the property of hydrocarbon is completely changed, right? And hence, those are primary functional groups. That are primary functional groups. Apart from many other functional groups are there that we are going to learn.
Okay. Yes, ma'am, done.
Functional group also you wrote?
No.
Please go for it. A group of atom which is responsible for properties of compound is known as functional group.
Yes, ma'am.
Okay. Now see, these are the functional groups. Few functional groups are given to you. Aldehyde, right? Aldehyde, it is represented with a condensed formula CHO, and in structure it is explained in the way C double bond OH.
Yes, ma'am.
In condensed form, it is written as a CHO. It is aldehyde. And in a structural way, it is represented as C double bond OH. And it is that minus sign is shown by the that is nothing but the valency. Okay, one bond can be
why does it form a double bond with oxygen and not hydrogen if it's a hydrocarbon? Then
mostly you need to learn this functional groups, right? So in aldehyde, ketone, carboxylic acid, carbon oxygen is in double bond.
So for these functional groups, carbon bonds with oxygen twice.
Yes. Okay. But then even in ester also, but then if you go to the ether, that time it will be in that manner. Carbon with one oxygen and then the carbon. So oxygen is bonded with the carbon in single bond. This is for ether.
Ether, okay.
Okay, so this basic changes you need to keep it in your mind.
Okay.
A lot of practice is essential.
Yeah, a lot. You need to figure out which. So, ma'am, we'll be practicing all these, all the functional groups here.
Yes, we have to, because we are going to see the number of reactions, no? In upcoming sessions, and even we are going to see the nomenclature. So that time you will understand.
Okay.
That differentiation. If it is essential, you can note down, and even after post chapter, once we have completed the chapter, I'll post the notes.
Yes, ma'am.
as I'm going
Okay.
to do for the metal and non-metal.
Yeah.
Yeah. Now see, what is given here? Aldehydes. It is CHO, C double bond O, H with single bond, means one valence is yet to fill. It can be attached to any other alkane group. So that alkane group with one loss of hydrogen. Because if there would be hydrogen, that will be complete compound, right? Now, if
Yeah.
I write here CH3, then it become what? Acetaldehyde.
Ma'am, what?
Acetaldehyde.
Acetaldehyde.
This group is called as acetyl group. And this is aldehyde. So this is
Ma'am,
acetaldehyde.
could you spell that?
Common name of this compound.
Ma'am, what's the chemical
How
name?
it's been called at our home to the person like Chintu, Bintu, Chintu, Bintu, what else? Bittu, right? Pinky, Minky, Manku kind of thing. The common name is acetaldehyde.
So, ma'am, what's the chemical name?
Yeah. But it's IUPAC nomenclature we are going to see later.
Oh my God.
It will be, this is ethane, right? Two carbons, 1 and 2.
Mm-hmm.
That is ethane.
Ethane. Yeah.
Okay. And as it is acetaldehyde, this is what?
Aldehyde.
Aldehyde, right? So this
Yeah.
we need to add here. So it is ethanol.
Ma'am, the chemical name is much easier. Ethanol.
IUPAC name, right? It's
Yeah.
easier.
Much easier.
Yes. But then common name, you need to keep it in your mind because it's widely used.
Yes,
Acetaldehyde.
ma'am.
Acetic acid
Acetaldehyde.
also you are aware, right? Acetic acid.
Yeah, acetic acid.
That structure is like this. CH3
CH3COOH.
bond OOH. You can
Yeah.
see what O where, sorry, not here. Carboxylic acid. It should be OH, huh?
Yeah.
Printing mistake here. Okay, so C double bond O OH. So this is your functional group. This is your methyl group. Correct?
Yeah.
CH4 cannot be come with there. And
Yeah.
if I have to write here ethane molecule instead of this, so it will be ethyl. It won't be ethane.
Yeah.
Understand?
That's
So
yes,
that's
ma'am.
because of the valency of carbon.
Yeah.
Now again 2 carbon. It is
So
also
ethyl.
ethane. IUPAC nomenclature, I'll say.
Acha,
Ethane.
okay.
Okay. After that, you have to write here oic acid.
Yeah,
Ethane.
ma'am. It's acetic acid, ethanoic acid is called the same. Yeah.
Yeah. Ethane, oic acid, whatever like number of carbon
And
that
where did the oic part come from?
ethanoic carboxylic acid. That rule has been set by IUPAC. I didn't do anything.
Okay, ma'am.
That rule is set by IUPAC. Okay.
Not
So
our fault.
and
Yes,
by
ma'am.
accepted, even I accepted, you too accepted.
Yes, ma'am.
Fine. Okay. Shall I erase it?
Yes, ma'am.
Understood?
Yeah.
Okay. So if you are interested, please note down these functional groups: aldehyde, ketone, carboxylic acid, and ester, which has carbon-oxygen double bond in their structures.
Mm-hmm.
You can distinguish easily with the other one. These. Just do, like remove this printing mistake. It should be C double
OH.
O O H. Okay.
Yes, ma'am. Can I note these down?
Yeah, please go for it. So nomenclature according to this functional group we will see tomorrow. I
Okay.
want like feel that today we are able to finish it. Even the tomorrow, I guess 2 periods we need to learn the nomenclatures because a lot of functional groups are present.
Yes, ma'am.
I have shown you the concepts, how many concepts are present in this chapter.
Yeah, there are quite a lot.
It will take a
But
lot
they'll
of
be quite interesting as well.
yeah, it's interesting if you understand. If you
Yeah.
want, it will be bouncer over the head.
Yes, ma'am. Ma'am, why are they kept in a bracket?
Because those are structures, right? So you should not confuse in between this and that. So these
So,
are
ma'am,
the
it looks like multiplication.
these are the structural representation, and these are the condensed form of those
Acha,
functions.
okay. Now it makes sense.
Got it?
Yeah.
If you want to note according to here, you can write the condensed form. And these are the structural forms.
Yeah.
Both are same, huh?
Yeah, but just different representations.
How I have shown for the alkane in same manner.
Mm-hmm.
Are you enjoying chemistry?
Yes, ma'am. It's quite interesting. Ma'am, for ester, it's COO, right? So
C double bond O because oxygen has two valencies, right? So
yeah,
this side also alkyl group will be there. Alkyl group can be represented with R. This side also alkyl group can be there. So those alkyl can be in same or different.
ma'am, I didn't understand.
I'll show you the example. So this is C double bond O and dash
Mm-hmm.
both the side, right? So
Yeah,
CH3 group can be present this side and even this side as well.
yeah,
Okay?
okay,
Understand? If I
yeah.
have to write different group, that too I will do CH3, C double bond O. I can write here C2H5 ethyl instead of methyl. So many different esters also can be present in that.
So something else can be. No, since it's COO, isn't it just going to be two oxygens? So
No,
it just
no,
double
no, no,
bonded.
no. This is hydrocarbon and this is your functional group. How functional group will go with another oxygen? Your functional group will change completely.
Acha, okay, never mind. Okay.
This is your functional group, right?
Yeah.
Where it is present in a hydrocarbon. If it is present in a hydrocarbon, other means wherever it is attached,
Then,
the hydrocarbon only means made up of hydrogen and carbon. That would
acha,
be
okay, okay.
alkane group. So
Yeah,
that
yeah.
we can't put. So we need to one hydrogen remove from that, and we have to put the alkyl group.
Yes, ma'am. Okay.
Understood?
Yeah.
Still confusion?
No. Understood.
Fine. See what is given here. Yeah. Single, double, and triple bonds are known as the primary functional groups, whereas rest all just now which we have seen, those are secondary functional.
Secondary.
Okay. The functional
Okay.
groups like ketone and ester always come in the middle of the compound. Just now you have seen,
Mm-hmm.
right? And
Yeah.
so they are called non-terminal functional groups. Terminal means at one side and
And
non-terminal means
ends. Yeah.
middle. Okay. The functional groups which do not come in the middle of the compound are known as terminal functional groups. Now, if we see aldehyde CH3 C double bond OH, it comes at the end,
Hmm.
right? These are terminal. If you see the ester CH3 C double bond O CH3, so it comes at the middle, hence it is
Yeah.
non-terminal. Even for the ketone CH3 C double bond O CH3. C double bond would be at middle.
Yeah. So aldehyde is a terminal functional group.
If it is at the end, then it is terminal. If it is in between the compound, then it is
Non-terminal.
non-terminal. Okay.
Yes.
Like double bond, triple bond, single bond. These will be primary functional groups. Rest all
Yeah.
are
And secondary functional groups. Aldehyde, ketone, all that.
understood?
Yeah. Ma'am, functional groups can never come in the beginning, right?
No, it's not like that. It can because haloalkane, if you see, it comes beginning as well. Haloalkane means halogen attached with alkane. This will be Cl CH3 or CH3Cl. Chloromethane.
Okay.
Commonly it's called as methyl chloride.
No, ma'am, but the functional groups, like
So
any
chlorine
of
is a functional group in this case.
it is.
Yes.
Oh, okay.
There are certain exceptions, but then most probably it comes after, it's at last. Or else in
Yes,
between.
ma'am. But it is possible for it to come in the front.
Yes, yes. Either at the terminal, and if it is non-terminal, then it is in between the compound.
Okay, ma'am.
Middle of the compound, you can say.
Yeah.
The rest of things we'll see tomorrow.
Sure, ma'am.
Yeah. Take care then. Bye.
Thank you, ma'am. Bye.
Most welcome.